it's really just not being disconnected. So disconnected is the first definition that we're going to apply here. And let's let E be a subset of any metric space such as R, and we will say that the set E is disconnected if there are open sets U1 and U2 of R in this case, such that E intersect U1 intersected with E intersect U2 is empty, and the union of those two relative complements or relative intersections would be all of E. And in the second condition, we need that when you intersect E with both U1 and U2, these are also non-empty. So let's draw a picture to try to better understand this. Let's draw a number line here, because we're pretending, at least for this example, that we're in R. Now in R, it's relatively simple that all the connected sets are really just intervals. So a disconnected set is going to be a set that's broken intervals or spaces in between intervals. So let's let one of them be, let's go here to here, and maybe let's put a closure on that one and go to here. So we'll consider this to be, this is disconnected because there's space in between them in the English sense. But let's see what this means in the mathematical sense. So E is a subset of a metric space. We have a subset of R here. I'm going to show that it's disconnected because I can demonstrate the existence of open sets U1 and U2 in this picture that disconnect the two pieces. So here's what they would look like. Let's draw an open interval around here and here. We'll call that one U1. And then we'll draw an open interval around here and here and call that U2. So notice, does this satisfy our definition here? Well, if we intersect E with U1, we just get this piece. If we intersect E with U2, we just get the red piece. And the intersection of those two objects together is null because they don't overlap at all. Then, if you take those two pieces, the red, and you union them together, you certainly get all of E. So it satisfies the first part. And notice that E intersected with U1 and E intersected with U2 are both non-empty. I kind of made them as open intervals covering the entire piece. So this would demonstrate that the red set is disconnected. Okay, let's try a more challenging example on this definition. Let's take a punctured interval. So there's our number line, and I will let my set E, which I'm going to say is disconnected, extend like so. We're going to take maybe, I can close it on one side if I want and then leave it open over here, but I'm going to make sure that it's open right there and extends to this side, however. So like that, and like this. So these two sets are disconnected, but they're disconnected only missing one single point, right? The point right there in the middle, X. So does this also satisfy the concept of being disconnected? Well, what open sets could we use? Well, on one hand, on the right-hand side, let's use the open interval that is actually going from there to there. Let's just call that our U2. Notice that it certainly intersects U2, non-empty, and it's covering all of the parts of E from that right-hand side. On the left-hand side, we can go here, and we have to go a little bit beyond. We can't use an open interval here, so we just extend it a little bit beyond. And notice that that is going to be our U1. So I've taken two open sets. It does go over the set E, but that's okay, because when we did our definition, in the definition we said that when we intersect it down to E, we're only supposed to get a part that's non-empty to begin with and covers on the other hand. So that would be a U1 and a U2 that would work for this punctured interval. Now with those examples from R1 under our belt, let's look at these as sets in R2. So pretend we're now in R2. I got these two blobs floating around, and it looks to me that they're pretty clearly disconnected, right? There's space in between them. So where would open sets be in this space that would be able to show or illustrate the disconnection between these two sets? Well, on one hand, let's take the open set that bubbles around this one. So there's an open set, right, using a dotted line to represent an open boundary. And then let's let the other one go like this. Whoops, I missed a little bit over there. There, and like that. So sorry, ignore this part that accidentally went inside because I wanted to cover the whole thing. So now those two open sets, although they do intersect each other, that's okay, because the intersection with E is just this part on one hand and the intersection with E with the blue open set would be just this set. So those two pieces, the green and the blue shaded pieces, don't intersect each other, and thus these two open sets illustrate that this particular picture is disconnected. Okay, and then finally, what does it mean then to be connected? Connected simply means that a set is not disconnected. So if it is not possible to find these open sets that I keep talking about to separate the pieces of your set, then that means that it must be connected